Welcome back to part 2 of the review of the midterm, which is the final for Trig, which I consider the big Trig final. Very good, everybody. Okay, remember a couple things before we get started. One, you will need a calculator for the test. Okay, you will need one. And on top of that, cell phones will not double as calculators. So if you don't have a calculator that is a standard issue calculator, either from TI or Communist Casio, you need to get one. Okay? No sharing of calculators either. It's all online, so you can't say I didn't warn you. All right. I feel like a commercial when I say that. This message is sponsored by no calculators, doubling of cell phones. All right. Let's keep moving. We're on inverse trig functions at this point. Remember, inverse trig functions output angles, right? They are giving us a ratio of sides, -1/2, all right? And we are being asked to find the inverse sine of that. Okay, here's the hard part. Where does inverse sine exist? I will tell you right now. It is, Chris, quadrants 1 and 4. So, because this thing is negative, we need to look to quadrant 4 to figure out where this is negative. It's right there. So does it make sense that this whole thing becomes -pi/6? Remember, it's not 11pi/6 because 11pi/6 means you had to go all the way this way. You can't do that. Okay? Cosine of -pi/6. Well, that is positive rad3/2. Okay? Cosine, sine inverse of -1/2. It's gonna be down here, right? So then we're trying to find cosine of -pi/6. No, because inverse sine of -rad3/2 would be the -pi/3, right? Sine of pi/6 is going to be 1/2, right? Because that's the lower elevation angle. Check your unit circle, Chris. Okay, now, what can they do to make this really, really hard? Well, they can do this. They can do something like number 58. So we'll do 2 from this section. Sine of tan inverse of 5/2. From here, if it's not on the unit circle, you must draw a triangle. Theta's here. Tangent is opposite over adjacent. So let's figure out what that hypotenuse is, and we'll move on. So sine theta, 5 squared plus 2 squared equals x squared. So that's 25 plus 4, so 29. 29 equals x squared. So this is rad 29. Sine of theta is going to be, in this problem, opposite over hypotenuse, which is 5 rad 29/29. And you're done. Alright? So that's your inverse trig function problems right there. How about... Yeah, what's up? Oh, did I move too fast there? I apologize. Let me see if I can't back that up there. No! They won't let me. I know, but it's in stone, so I can't. It's almost like trying to change Jim Raynor's name in StarCraft. You can't do it. Oh, is it undo? Oh, sorry, redo. Sorry, I was trying to hit redo. Michael, I will tell you which ones I want you to rationalize and which ones I don't. Sorry, coming off a debate tournament, I'm a little rusty with technology and math. Give me a few days. I'll get back to it. We good? Yes? Dustin. Negative? Oh, sorry. Yes, one of them's negative. So that means that this answer should be negative also. I think. Yeah. Semantics. Concept is what I care about. Okay. All right. Before we do anything, I'm going to graph a few of these. 61 through 68, it's just all graphing. Actually, 61 through 71 is all graphing. So let's go ahead and graph the inverse trig functions first. So let's see here. Number 67. Sine inverse of x equals theta. Let's say y equals sine inverse x. That way it just kind of looks a little more familiar. Okay, remember, sine inverse starts from -1 and 1, and it begins at this negative pi over 2 and this pi over 2. And then from here, it does that. And remember, the dots on the midterm, which, by the way, is the final for trig, you must also identify the domain, the range, and the quadrants. Domain is -1 to 1. Range is negative pi over 2 to positive pi over 2. The quadrants are 1 and 4. 68. Cosine y equals cosine inverse of x. I like to draw my graph like this. Dot, concave down, concave up. -1 to 1, 0 to pi. There you go. So then your domain is going to be from -1 to 1. Range is going to be from 0 to pi. And then quadrants are going to be 1 and 2. So, was that you? Okay, sorry. Beth, good job. I'm going to do one that's not on the worksheet, and that's going to be to graph inverse tangent. Okay. Let's take a look at inverse tangent. Am I moving too fast for you guys? What I need you guys to do is I need you guys to join debate and have you guys participate in spread debate. You guys will get fast at writing. You guys will get really fast. I mean, what it is that in the policy rounds they do what's called spread debate. I'll show you guys a video of it at the end of class. And you have to be able to keep up with their notes. Otherwise, you're going to be totally screwed. Chris. Which is also the midterm. Yes, I will. You are required to write those down. Are we good? No, I'm not going to give you the box, but I'm going to tell you. Okay, so inverse tangent looks like this. All right, everyone. We got asymptotes up at the top, asymptotes on the bottom. Those asymptotes are located at negative pi over 2 and pi over 2. From here, what letter of the alphabet does inverse tangent look like? An S. Oops, and it's not supposed to cross that asymptote like that. It's supposed to do this. Okay? Arrows, they're already up there. The domain, the range, the quadrants. Domain is I'm sorry, just kidding. That's not that. What is it? Negative infinity to positive infinity, or all real numbers, whatever you feel is appropriate. The range is going to be from negative pi over 2 to pi over 2. And then the quadrants are 1 and 4. Go ahead and take a second and copy those down. I'll pause while you do that. All right, let's move on to some graphing, everybody. Okay, let's take a look. Thank you. Let's take a look at number 71. Okay, y equals sine of parentheses 3x plus pi over 3 minus 3. Remember, before we graph anything, we have to factor out that 3. So it becomes x plus pi over 9 minus 3 on the outside. Okay, so from here, this is the function we're going to look at. It's this bottom one. So we need to identify the amplitude. We need to identify the vertical shift. Then we need to identify the phase shift. And then we identify the new period. The amplitude looks like in this function is 1. Let's see, the vertical shift is -3. The phase shift is negative pi over 9. And then the new period looks like 2 pi over 3. But remember, we want to find a common denominator, so it looks like it's going to be times 3, so 6 pi over 9. Raise your hands, that looks kind of familiar. Yes, good. Okay, from here we draw our line. We are shifted down 3 units, and that's not down enough. Shifted down 3 units. Remember, I want to see the shift. This is -3. The amplitude is 1, so it's going to go as far as -2 and as low as -4. Yes? From here, we draw standard sine. Whoa, that's not standard at all, but that's okay. I can live with that. Okay? All right. We started at -pi/9. We ended at 5pi/9. Yes? Because we travel a distance of 6pi/9. Okay, cool. So now the middle point is going to be the average of the two. So -pi plus 5 is 4pi/9 divided by 2 is 2pi/9. Cool. Now, the middle, or rather the peak. 2pi minus pi is 1pi, but that's odd, so it's going to be pi over what? Pi over 18. And then this point's going to be 7pi, but that's odd, so it's going to be 7pi over 18. If you run into a situation where you might have to reduce your values, don't worry about it. It's okay. The y-axis goes in between the negative and positive value. Remember, you guesstimate the area of the y-axis, or not the area, the location of the y-axis. That should be what we consider a piece of cake. Max. Okay. It has to match the phase shift. Or at least you want it to. It doesn't have to do anything it doesn't want to. It has to match the phase shift. So, I matched my period by multiplying the top and bottom by 3. So that it would match the phase shift. Okay? Cool. Alright, I'm not going to draw this one, but I want us to look at number 73. We're going to write the equation for one sine, one cosine. So, in order to do this, we need to identify a vertical shift, we need to identify an amplitude, we need to identify a frequency, but before that we need to define a period. So, does it make sense that the vertical shift on number 73 is -2? We're looking at 73, right? The vertical shift is -2. And then we're going as far up as +3 and as far down as -7, which means our amplitude is going to be 5. Good. We can't figure out frequency without figuring out period. Now, the period of this function is, I'm going to say from 25 to -5, I'm going to peak to peak. So 25 minus -5 is going to be 30. Now, I feel that this is in radians. I don't know why. I feel that it's in radians, so I'm going to do it in radians. Frequency is going to be 2pi divided by 30, which is pi over 15. From here, I have all the information that I need to write the equation in both one sine and one cosine. So, the sine is going to look like this. Y equals 5 sine of, let's see, frequency is going to be pi over 15 times something, let's see, some kind of x and then -2. Cosine is going to look the same way. 5 cosine pi over 15, x, and then -2. Now, to figure that out, we need to figure out the phase shift. So, ooh, that's kind of brutal. Oh, okay. Cosine's easier. Who can phase shift cosine to make sure that it's positive? Chris. +5, why not? We're going to shift it to the left 5, that way it's positive. Okay. Sine's going to be a little harder because there's no clear point of intersection. So, I'm going to do the average of 10 to 25. Okay, so that's 35 divided by 2. So, if I shift it to the right by that much, it's going to be -35 over 2 spaces. Duh? Alright. Okay, I'm going to do one more for you guys. Alright? And then I'll deal with identities period 4. Solve the trig function. That's easy. Okay. Alright, so let's take a look at something like 79. They give you cosine theta equals -4 over 7. Theta is between, crud, it's easier, 90 180. Okay. The fact that the angle is between 90 and 180 means we are in quadrant 2. So I draw a quadrant 2 triangle. I make theta the origin angle. Remember, cosine is negative in the second quadrant, so it's going to be negative 4 over 7 here. From here, we find the opposite sign, so it's the opposite side, so it's going to be negative 4 squared plus, let's see, b squared equals 7 squared, so that's going to be 16, plus b squared equals 49. B squared equals 49 minus 16. 33. So this is going to be rad 33. That's all side work. Now, we need to find sine theta. That's all they're asking us to do. So sine is opposite over hypotenuse, so it's going to be rad 33 over 7, and you are done. And done. Okay? All right. Let's do an identity. Who cares? Oh, actually, you know what? Someone asked for 85. Was that you or period 5? Or period 4? Period 4, okay. So then I'll save that for them. Okay, Cameron, so we'll do that one. Okay. Write this down real quick. Okay. Obviously, the left side is easier. What I'm going to do is I'm going to try and find a common denominator first. Does that make sense, Cameron? So I need to multiply the top on the left by secant theta plus 1. This is going to secant theta minus 1. So what I get is if I multiply the top and bottoms, I get cosine theta times secant theta plus 1 plus cosine theta times secant theta minus 1 all over secant squared theta minus 1 equals 2 cotangent squared theta. Okay, now, let me see here. Okay, secant squared theta minus 1, that's a Pythagorean identity. I believe that is tangent. Cameron, I'm going to go ahead and distribute this in. Okay? So I'm going to, actually, you know what? Do I want to do that? Okay, whatever. Not that it matters. I'm going to distribute. So cosine times secant, you know what that is, Cameron? Okay, cosine times secant, they're reciprocals, which means it's going to be 1. Okay? And that's going to be plus cosine theta. Yeah? Here, I'm going to get 1 minus cosine theta. Yeah? And remember, all that while they were being added in the center. Okay, so now, the cosines are going to cancel each other out. So far, so good. 1 plus 1 is 2. So I have 2 over tan squared theta equals 2 cotan squared theta. Cameron, do you know what the last thing we have to do with this problem is? Max? Nope. Cheap. You must bring the tangent squared up. So 2 cotangent squared theta equals 2 cotangent squared theta. Yep. Tangent squared on the bottom floats up to the top. So, what's up? Oh, I'm sorry. So it should be pretty clear what's happening here, right? So you don't need to see the bottom work? Okay, cool. So I'm going to pause it real quick.